Welcome everyone in the part second of NMR spectroscopic problems. In this video, we are going to learn structure determination of organic compound by using PMR spectral data. Before going to problems, we are going to see some important things. The chemical shift values of certain group of protons. While solving PMR spectroscopy problem, it is very important to know chemical shift value of certain group of protons. If methyl group is attached to sp3 hybridized carbon, then its chemical shift range is from 0.89 to 1 delta ppm. That is, it is near about 0.89 delta ppm. If methyl group is attached to carbonyl group, then the downfield effect is seen and the chemical shift value is 2.1. If methyl group is directly attached to oxygen atom, that is electronegative atom, then its chemical shift value again goes to downfield and the value is 3.4. For aldehyde group proton, due to anisotropic effect, its chemical shift value is near about 9.7 delta ppm. For carboxylic acid group also, the downfield effect is seen and its chemical shift value is 10 to 12 delta ppm. These are the characteristic group values for certain group of protons. If hydrogen or proton is present on sp2 hybridized carbon atom, then its chemical shift value range is 4 to 6 delta ppm. In case of aromatic compounds, the chemical shift value is 7 to 8 delta ppm. In case of benzene, its value is 7.27. In case of hydroxyl group, that is OH, chemical shift range is from 4.0 to 5.0. But if alcohol is pure in nature, then its chemical shift value may varies from 1.5 to 5.0 delta ppm. In case of amines, their chemical shift value range is 3.0 to 4.0. These are the some important group chemical shift values that have to be remembered while solving NMR spectroscopic problems. PMR, that is NMR spectroscopic problems, are solved by following steps. The first step is determination of site of unsaturation. In previous video, that is in part 1, I have given the idea about how site of unsaturation or double bond equivalent is determined. Its link is given in the description. If signal height ratio is given, then determine ratio of protons and then actual number of protons of each signal. By knowing the ratio of protons, we can determine the protons responsible for each signal. From the given spectral data, assign the probable groups present for each signal. For that, use n+1 rule for first order splitting. First order splitting takes place due to vicinal and geminal coupling, that also remember. By considering all above facts, determine the correct structure of organic compound. Assign each group of protons by their chemical shift values and their splitting pattern. And remember that for fast exchanging groups like OH, SH, NH2, they always gives broad singlet in the spectra as such protons are not coupled with adjacent group of protons. For example, in case of ethanol, CH3 group gives triplet as it is adjacent to CH2 group. That methyl group proton, there are two non-equivalent adjacent protons, therefore it gives triplet according to n+1 rule. While CH2 group proton gives quartet as it is adjacent to methyl group proton and it couples with methyl group proton, therefore it gives quartet, and it not couples with hydroxyl group proton. Although it is adjacent group proton, methylene group proton not couples with OH group proton, and therefore splitting of the signal due to OH group not takes place. The splitting of signal takes place only due to methyl group, and methylene group gives the quartet in the spectra. OH group gives singlet as it not couples with methylene group proton. Therefore, groups like OH, SH, NH2, etc. they not couples with adjacent group protons, and they always gives broad signal in the spectra. By remembering that facts, now we see the examples one by one. This is problem number 1. The molecular formula given is C4H8O. The PMR data given is the first signal 0.9 delta triplet 15 mm, 2.4 delta quartet 10 mm, 2.1 delta singlet 15 mm. In this example, the number of protons are not given, but the signal height is given. Therefore, we have to determine first signal height ratio and the site of unsaturation. Now we see the solution for that. The site of unsaturation for this compound is 1. By neglecting oxygen atom, the molecular formula becomes C4H8. The corresponding saturated formula is C4H10. There are 2 hydrogen atoms less, therefore its site of unsaturation is 1. How site of unsaturation is calculated? That is given in the previous video. Please see that. When site of unsaturation is 1, it indicates presence of a pi bond. It may be carbon double bond carbon or carbon double bond oxygen. Then the signal height ratio is 15 to 10 to 15, and its ratio becomes 3 to 2 to 3. And the sum of that 3 numbers is 8. And the number of protons in the molecule are also 8. Therefore, this ratio corresponds to number of protons present in the molecule. And the spectral data can be written as molecular formula C4H8O, and the spectral data, the first signal is 0.9 delta 3H triplet. 3H corresponds to 15 mm. Similarly, 2.4 delta 2H quartet, 2.1 3H singlet. Now we see each signal one by one. The first signal 0.9 delta 3H triplet. This is the signal of 3 protons, that is of methyl group, and the triplet indicates that there are 2 non-equivalent adjacent protons, that is there is presence of methylene group proton adjacent to methyl group. Therefore, such type of skeleton is present in the molecule CH3CH2. That CH3 group gives triplet in the spectra. 2.4 2H quartet. This is the signal of 2 protons, that is methylene group, and the quartet indicates that there are 3 non-equivalent adjacent protons, that is presence of methyl group adjacent to methylene group, and the downfield effect indicates that CH2 group proton is attached to carbonyl group. Then such type of skeleton is present in the molecule. Then third signal is 2.1 3H singlet. This is the signal of 3 protons, that is methyl group. Singlet indicates that there is no any non-equivalent adjacent proton, and the downfield effect indicates that it is attached to carbonyl group. Therefore, presence of CH3 CO group. It gives singlet as there is no hydrogen atom on adjacent carbon atom. And by considering these facts, the correct structure of the compound is like this. There are 3 sets of protons. It gives 3 signals in the NMR spectra. The first signal is triplet, which is obtained, then quartet, then singlet, and which are obtained at 0.9 delta, 2.4 delta, and 2.1 delta respectively. These are the signals, and this is the chemical shift values of each group of protons. Now we see problem number 2. The molecular formula is C3H6O and the PMR data is like this. Now we see the solution for that. The site of unsaturation for this compound also, it is 1, which indicates presence of carbon double bond carbon or carbon double bond oxygen. If molecular formula contains oxygen atom, then there is a possibility of carbon double bond oxygen. The first signal 1.1 delta 3H triplet. This is the signal of 3 protons, that is methyl group. Triplet indicates there are 2 non-equivalent adjacent protons, that is CH2 group, that is presence of CH3 CH2 group. The second signal 2.4 2H quartet. This is the signal of 2 protons, that is CH2 group. Quartet indicates there are 3 non-equivalent adjacent protons, that is presence of methyl group, and the downfield effect indicates it is attached to carbonyl group. Such type of skeleton is present in the molecule. The third signal is at very downfield 11.2 1H singlet, and we know that that signal is for COOH group, which is at downfield, which indicates presence of COOH group. And thus the structure of the compound is, this is the structure of the compound, and these are the signals for each group of protons. CH3 gives triplet, CH2 gives quartet, and COOH gives singlet. CH3 gives triplet as there are 2 non-equivalent adjacent protons. CH2 gives quartet as there are 3 non-equivalent adjacent protons, and the OH group proton gives singlet. And the corresponding chemical shift values are like this. This is the value for methyl group proton 1.1 delta, 2.4 for methylene group protons, and for COOH group the chemical shift value is 11.2 delta. And that value we have to remember, for COOH group chemical shift values are from 10 to 12 delta, and that is the correct structure for the organic compound. Then problem number 3. This is the problem. Molecular formula C4H10O2. There are only 2 signals, 3.46H singlet and 3.8 4H singlet. That is, this compound there are only 2 set of protons. Now we see solution. Site of unsaturation is 0. In that case, the molecular formula is C4H10O2. Neglect oxygen, the formula becomes C4H10. Corresponding saturated formula is also C4H10. Therefore, site of unsaturation is 0. That is, this compound not contains any unsaturation. That is, it is a acyclic and saturated compound. The first signal 3.46H singlet, and this is the signal of 6 protons, and which gives the clue about there should be presence of 2 methyl group protons which are equivalent. 2 methyl group protons are equivalent. Singlet indicates that non-equivalent adjacent protons are absent. For that methyl group protons, non-equivalent adjacent group protons are not present. The downfield effect indicates that these groups are attached to electronegative oxygen atom, that is presence of 2 methoxy groups. The second signal is of 4 protons, 3.8 4H singlet, and 4 protons gives the clue that there should be 2 CH2 group protons equivalent, and the singlet indicates that there is no non-equivalent adjacent proton on adjacent carbon atom. The downfield effect indicates that it is attached to electronegative oxygen atom. Such type of 2 OCH2 groups are present in the compound. And by considering these facts, the structure of the compound is like this. In that case, there are two set of protons. Methyl group proton, there is one set, and methylene group proton, there is another set. It gives two signals in the NMR spectrum. One is for methyl group protons and another is for methylene group protons. And these are the corresponding chemical shift values for that protons. Then problem number 4. Molecular formula C10H14. Spectral data is 0.919H singlet. And second signal is 7.25H singlet. In this example also there are only two set of protons. Now we see the solution. The site of unsaturation is 4 for that compound, and the site of unsaturation is 4, and there is a one signal at 7.2 delta, and which is of 5H singlet, and it is in aromatic region, which indicates presence of monosubstituted benzene. For phenyl group protons, the site of unsaturation is 4. The first signal 0.91 delta 9H singlet. This is the signal of 9 protons, and which shows that 3 methyl group protons are equivalent, and the singlet indicates that non-equivalent adjacent protons are absent, and the value is at upfield, which indicates that these protons are shielded protons and also indicates the presence of tertiary butyl group. The next signal is 7.25H singlet. This is the signal of 5 protons, and that region is in aromatic region, and the signal indicates presence of monosubstituted benzene. It also satisfies 4 site of unsaturation, and this is a monosubstituted benzene. And this is a very simple example, and by considering these facts, the structure of the compound is like this. Tertiary butyl benzene, there are only two set of protons. All these 3 methyl group protons are equivalent. They give the signal of 9 protons, and they give the singlet at 0.91 delta. All phenyl group protons are also equivalent, and it gives the singlet at 7.2 delta. And this is the solution for this problem. Then next example, problem number 5. Molecular formula C7H8O, and the spectral data given as follows. The site of unsaturation for this compound is 4. One signal 5H singlet in aromatic region, which indicates presence of monosubstituted benzene. The first signal is 3.7 delta 1H singlet, the signal of one proton, and the singlet and downfield effect indicates presence of hydroxyl group. That is, this is the signal is of OH group, signal of one proton. The next signal is at 4.4 delta 2H singlet. In that case, it indicates presence of CH2 group proton. This is the signal of 2 protons, and that is presence of methylene group proton, and the signal at downfield. The next signal is 7.1 5H singlet. This is the signal of 5 protons. It is in aromatic region, and this signal also indicates presence of monosubstituted benzene. It also satisfies 4 sites of unsaturation. And by considering these facts, the structure of the compound is like this. There are 3 set of protons. Phenyl group proton gives singlet at 7.1 delta. OH group proton gives the singlet at 3.7 delta, and CH2 group proton gives singlet at 4.4 delta. And this is the answer for this problem. Then problem number 6. The molecular formula C3H6Bri. The compound contains halogen atoms. These are the signals for that problem: 2.27 2H quintet, 3.5 2H triplet, 3.7 delta 2H triplet. And the solution is like this. The site of unsaturation for this compound is 0 as halogen atoms are replaced by hydrogen, and the formula becomes C3H8, and the corresponding saturated formula is also C3H8. Therefore, site of unsaturation is 0, which indicates compound is acyclic and saturated in nature. The first signal 2.27 2H quintet. This is the signal of 2 protons, that is of CH2 group proton. Quintet indicates that there are 4 non-equivalent adjacent protons. Such type of skeleton is present in the compound. This is the CH2 group proton, and these 2 adjacent CH2 group protons are not equivalent. The next signal is 3.5 2H triplet. This is the signal of 2 protons, that is CH2 group. Triplet indicates that there are 2 non-equivalent adjacent protons, that is presence of CH2 group, and the downfield effect indicates that it is attached to electronegative atom, that is bromine atom, that is presence of CH2 Br group. The third signal 3.7 2H triplet, similar to above signal. This is the signal of 2 protons. Triplet indicates there are 2 non-equivalent adjacent protons, and downfield effect indicates it is attached to chlorine atom, that is CH2 Cl. And therefore the structure of the compound is like this. This is a acyclic saturated compound. There are 3 set of protons. All these methylene group protons are not equivalent. This CH2 group is attached to chlorine. This CH2 group is attached to bromine, and that CH2, its chemical environment is different. And it gives 3 signals in the NMR spectra. It gives triplet at downfield 3.7 as chlorine is more electronegative than bromine. Therefore, its signal is at downfield 3.7. The signal of central methylene group proton, it gives quintet as there are 4 non-equivalent adjacent protons. The signal is obtained at 2.27. And the signal for CH2Br is triplet 3.5 delta. Now next example, problem number 7, molecular formula C8H7N. It gives 2 signals in the NMR spectra, 1.8 3H singlet and 7.04H singlet. In that case, the site of unsaturation is 6, because as nitrogen is present, it is replaced by CH, and the corresponding saturated formula is driven, and from that the site of unsaturation is 6. The first signal 1.8 3H singlet. This is the signal of 3 protons, that is CH3 group. Singlet indicates that non-equivalent adjacent protons are absent, and the downfield effect indicates it is attached to aromatic ring. This is 1.8 delta 3H singlet, that is it is attached to slightly downfield effect and it is attached to aromatic ring. The next signal is 7.04H singlet. This signal is of 4 protons and it is in aromatic region, and there are 4 sites of unsaturation that indicates presence of di-substituted benzene, and 4 hydrogen atoms, they are equivalent. Therefore, it is a para di-substituted benzene, and the remaining 2 sites of unsaturation are present in cyanide group, carbon triple bond nitrogen group, and thus it satisfies 6 sites of unsaturation, 4 for phenyl ring and 2 for cyanide group. And thus, by considering these facts, the correct structure of the compound is like this. There are 2 sets of protons, phenyl group protons, which gives singlet at 7.0 delta, and methyl group protons that gives singlet at 1.8 delta. Thus, in this video, we see number of examples on spectroscopic problems. Keep learning with me. Thanks for watching this video.